part two of working with logarithms. A couple more skills. Simplify using the inverse. So what we did in class today, we learned that we reviewed that the inverse undoes the original, and we looked at the graphs of them, and we learned that it's symmetric about the line y equals x. There's symmetry. But it also helps us, using the inverse will help us simplify expressions. So like if we have 8, watch how easy this is, 8 raised to the log base 8 of x. And I want to simplify this expression. Because these are inverses of each other, it looks like a complicated expression, but because we're doing an 8 raised to a power, that's exponential, and then we're doing log same base 8, they undo each other, so the answer is x. And then we move on. It's that easy. So let's try log base 7 of 7 raised to the negative 3x. What do you think the answer is? We have a base of 7, and we're doing 7 raised to a power. They undo each other. So the answer is negative 3x when you simplify. Let's try another one. Let's say we have log base 2. Let's say they're different bases of 64 raised to the x. Well, these are different bases, but we can make them the same like this. You would just do log base 2, and 64, what is that in base 2? It's 2 raised to the what? You can do guess and check. Yeah, good. It's 2 to the 6th power. So now they just undo each other. Log base 2 and 2 to a power, they just undo each other. The answer is 6x. Let's try one last one. Let's try e raised to the natural log of 20. Very, very simple, because natural log is base e already, and this is the base is e. They undo each other, so you simply get 20 exactly. So that is done. You just the e and the natural log cancel each other out, and you just get 20. Why is the notation for natural log ln? I don't know the history behind how that came about. That's a good question. So the last thing is find the inverse of an equation. To find the inverse of an equation, so I think we are going to we're just going to do a couple examples. So if you have y equals 4 to the x, okay, and I want to find the inverse, all I have to do is write it in logarithmic form. We would just switch x and y and try to solve for y, but you can't, and you tried this in the classwork today. You have x equals 4 to the y, but how do you, question mark, how do you solve for y? You can't. So, but you just rewrite it, so the inverse, you just write it in log form. It'd be log, what do you think the base is? What's the base here? 4, log base 4 of x. And that is how that's the inverse of 4 raised to a power is log base 4 of x. So let's look at another example. Let's say you have, let's start something like this, y equals natural log base e to the x plus 3, and I want to find the inverse. We're just going to switch x and y. Switch x and y. So we would get x equals natural log base e to the y plus 3. And now we just use what we know about, you can't just solve for y, but you can write it in exponential form like this. E raised to the x power, e is the base, e raised to the x power equals y plus 3, and we're almost done. Just solve for y by subtracting 3 from each side, so you get y equals e to the x minus 3. And that would undo the original equation.